Yes.
Yeah, Sanket. So it'll be great to hear from you, and if you can share your screen also. Yeah.
Yeah,
We've been
sure.
doing all these sessions interactively.
Yes.
And why actually, I should also say, right, introduce yourself, and then also after you've presented, we can also go around the participants, and everyone can also introduce themselves
Yes.
briefly. Even I don't know any of you personally.
Yes. So my name is Sanket. Actually, I am from Nashik city. Presently, I am working as a research associate at Azim Premji University. And also along with that, I tried to work on many other small projects which had a keen interest in data analytics related. So these are my some simple introduction. And also I have a small blog on a WordPress where most of the time I write about whichever interesting things I find while analyzing some economics data sets. So
Great.
recently, when I came into contact with Core Stack Geospatial Challenge, so I find it interesting to whether it is possible to analyze the market proximity and market patterns. So it will help to to uh, understand in policy framework. So narrow it down to one simple Nashik district where it contained 15 talukas. So I tried to, I will also share the PPT. So is my screen is visible? Hello?
Yeah, your screen is
Yes.
visible, Sanket.
Yes. So in this dashboard, I start with where exactly I get my data set from. So I get a daily frequency data sets from data.gov.in. So they provide a daily or a weekly market prices of data of different commodities. So we can filter out a specific commodity or vegetable, let's say an onion, and also from CoreStack website, from explorer.corestack.org website, I get a data at Tehsil level uh, and Nashik district level. So they provided me administrative boundary, a land use level 3 agriculture layer, so where we can identify kharif, non-kharif, double cropping and triple cropping pattern across different talukas. And also they provide a interesting polygon shape data with a remote water sense body where we can also trace the lake and different rivers where exactly availability of water. For this dashboard, I use a Python and MS Office software to analyze and filter and slice and dice the data to work according to my needs. So let's jump back onto the uh, our dashboard. So here initially the you can see that Nashik contains 15 different taluka, but what we get from the data set, the market prices, and there are some district don't have mandis, so they don't have a actual mandis, so then they don't provide a data on onion market prices. But let's say a Nifad, the taluka you can see at the center point, where along with the mandi there are different traders activated here, so they also trade, so their information is also there. So we can see the different mandi and all of the traders location all together. So most of these are concentrated at the central and eastern part of the Nasik. If we try to look at the market price dynamics across the year since 2017 to 2025, if we plot the heat map of each month and aggregate those prices, we can see that over a period of time there is a rise in a price. And 2024 is the year where the prices of onion was a sky high, especially during November, December, and January month. The same thing can be spotted in 2019 during April, May, or June month during this time period. So we can get a simple idea how the market price affect all of those things. Later on, if we analyze where actually all of this market uh, cluster together, and if we try to filter it out top 10% of those things, we can plot a hotspot of 2017-18, where we can see that I have plotted a water bodies and also intensified hotspot of single kharif crop plantations. So where here we can see that the most of the kharif crop plantation was happening in a eastern Nashik talukas. Here you can see that. And the Nashik district itself is divided in two different phenomena. One of that, the Nashik district is famous for a onion, and where most of the market is dominated by a Lasalgaon onion market, where we can see a large number of influential price and market over a later period of time. And afterwards, also if we slide this slide bar, and if we can check the recent 2024-25 data, that we can see that the single kharif crop farming is degraded over a period of time, where hotspots get reduced and most of the people are trying to focus on double or triple uh, crop patterns. So the we can see that using this graph. Now let's jump on a talukas. So the onion prices, not every single taluka have a market mandi, hence most of the talukas don't represent the market prices. Now next we will go to the multi-temporal analysis. Here what exactly I have done that I have separated the values given by LU-LC layers, and I tried to plot, and also I tried to plot of market mandis. Here you can see that in Bagalan Taluka, where entire taluka is predominantly dominated by single kharif. Now we know that the onion is all weather vegetable, and also it is predominantly planted as a kharif crop, right? So we can see the pattern over here. So in Baglan Taluka, there are single kharif and double cropping pattern. We can see that, and at the same time, this pattern also match on a hotspot patterns, like in a north and south layer. Here you can see the hotspots, which you can see the clearly that how the area of agriculture land divided altogether. And same thing we can observe over the period of time. If we move this cursor ahead, we can see the change in the pattern, right?
A
So in
quick
2000,
clarification, Sanket, sorry to interrupt. What are the units on the map on the right? The left, I mean the legend that's there.
yes, this one.
Yeah, hotspot intensity.
Yes, so this is uh, now entire Nashik district is predominantly have get the agriculture crop in single and double crop farming. So I set those two values, and based on those two value, I tried to plot the hotspot. So these are the defining those two crops.
Are these H3 hexagons on
Yes, hexagons, H-beans. Because when I tried to plot a hotspot, so it took too much time, and I don't have that much resources to plot. So hence I use a hexabin. So it will give a quick result, and we can set
yeah,
the,
it's very
yes.
efficient.
So
Yeah.
it is very efficient in that case. Yes. So entire district, all of these talukas, I tried to plot a hotspot for those two values: single kharif crop plantation and double kharif crop plantation. So we can see the pattern change across the period of time. Now some district pattern change for, or some district pattern remains same. So in Baglan during 2017 to 19, there was stability in a single kharif crop. But after 2019-20, there is an increase in double cropping. The same thing we can show, we can also see when we see the year on year change of all of these patterns. So here I tried to uh, uh, do the aggregation of all the pixels which we can see on those LULC map. Let's say single kharif. So over a period of time, we can measure the change. Let's say those green values are reducing over the period of time on the map. So we can simply plot that in a bar graph. So,
Did
so
you
here,
find any correlation with distance to mandis or anything like in the previous year?
uh, not in all single talukas, but only in few talukas, I see those changes over a period of time. Let's assume that around 5 to 10 kilometers, you can see the differential pattern change, because over a period of time the hotspot change its location from one place to another. In that case, there will be a small change in the distances. Hence, the market proximities to mandis, it get affected.
Yes, thanks. Can you
Yes.
please still the previous chart? Um, yeah. So can you please explain a little bit a bit more?
Yes. So
So the closer they are to Mondays, are there? Is this because not many plantations are that close? That is why the number near zero is lesser, and then within 5 to 10 kilometers, within 5 to 7.5 kilometers or something like that, there are more uh, like.
yes, I can put the same thing in simple perspectives. Let's assume that in a southern part of the Nashik taluka, Bagland, let's say presently here is the Mandi. So you can see that from this location, hotspots are near, right? If you draw the circles around that 5 kilometer, 10 kilometer, 15 kilometers, these hotspots are near. So we can trace using this hotspot, yes, the crop production of single kharif crop and double kharif crop, they are closer to those mandis location. And if I move the slide bar, let's assume that here, now it doesn't affect that much, but in some cases, let's say Nandgaon. In a Nandgaon in 2023-24, we can see some spikes in onion prices, right? It is predominantly dominated by single kharif crop patterns. In same thing, if we see that all of those hot spots are closer to market. So the single or double kharif crop plantation, those farmer can access the mandi within 0 to 15 kilometers. But if we change over a period of time, so the pattern also shifted, right? In that case, here in a Nandgaon, now the most of the farmers decided to do a single non-kharif plantation in their farm, right? Because of it, let's say in 2023-24, also you can see there is a shock to the onion prices, right? So we can try to correlate to that. Hence, the hotspot is predominantly represented in a top north corner. In that case, proximity to the mandis increases.
Yeah. Okay, thanks.
Yes.
Does anyone other animals else has any questions?
Uh, I also try to measure the year-on-year change of those things. So the simple bar plot representation will be also helpful. Hence, in 2024-25, there is a sharp increase in triple cropping pattern, but it can directly says that the onion cannot be planted with three different crops. In such a case, if we observe the another data to validate these findings, there must be a fall in onion production. So it gave a different scope to all other dimensions. Now, I have also another question to, let's say, every single time the farmers try to plant a different kind of crops, right? So in that case, can we measure the stability over a period of time? Most of the central part of some talukas, some district or some municipal corporations area, urbanization increases over the period of time. In that case, how can we trace that in some one point of village, uh, some particular farmer or a people are uh, planting the onion crops or single kharif crop over the period of time. Now let's assume that single kharif crop is represented by the value of 9. So over a period of time since 2017 to 2024, we can see that most of the north or northwestern side villages from the Nandgaon Tahsil, we can say that they didn't change their farming pattern across this period, right? So hence, to measure this, I plotted a transition map for that. Yes, and another interesting thing I also want to show you that the Nifad is one of the central tahsil where different mandis and traders are also located. But at the same time, if we see the transition map, so not much things is happening. Only a north part and southern part of few villages where we can see there is a stable kharif crop plantation is there. In the same way, if we can observe in a Lassalgaon price chart, there are multiple price shocks occur across the period of time. During initial 2018 year, 2020, 2021, and another major shocks occurred during 2024 mid. So same thing can be we can also observe in a market price dynamics heat map. Now, if we want to have a take a look at it, so Lasalgaon remain a top producer of uh, onions. Hence, the hotspots are spread across the map, right? So it again become tricky to do that, but market proximity to those all of those mandis are pretty good, and even those farmer from different villages, they have to travel very less to sell their onions in this market or any other vegetables in that market. So we can observe this using hotspots. And entire tahsil not only represent one pattern over a period of time, it represent a mixed pattern, but they did not produce any single non-kharif crops over a period of time. So mostly it is distributed between single, double, and triple crops. Yeah.
Yeah, this is very cool, Sanket.
Yes.
Do people have questions? I
Yes. And over a period of time, uh, concentrations of hotspots, which was concentrated in the southern part of a NIFAD, where we can see mostly triple and non-single kharif plants are increasing. So that is also a concerning point. So this is what I want to present. And for this, I want to thank Core Stack and Core Stack team for providing me data and guiding me most of the period of time. So thank you.
Great. No, this is super interesting, Sanket. I think, I mean, we can all clearly see, right, that there's so much value if we start putting different data sets together. I think, right, like locating the mandis and then comparing uh, how the price gets reflected in the cropping pattern in that year. This is very interesting. Um, yeah. I think it will also be, if you push this further, actually, we were talking about a couple of things that um, what we can try in the long run is that this dashboard that Sanket has started to develop, potentially it can evolve into some kind of an agriculture insights dashboard. Um, there can be more information which we can start layering, like there's rainfall that we also track in the core stack. Then we also identify drought and non-drought years. Yeah. So that can, just like price is one factor, and we're trying to see how price gets reflected in agri patterns. Similarly, we can also then, if we start layering the drought against the agri patterns, then that can be another interesting thing to analyze. Um, Another is about the mandi positioning, right? That how does the agri pattern change with respect to the mandi location, mandi proximity? In the
Yes.
same way,
Uh,
yeah,
at
yeah,
some point, I want to point out that not all the tahsils have mandi locations. So
right,
most of the time, them prefer one of the famous relevant location. For example,
mhm,
in Nashik district, Lasalgaon Mandi, or some
right,
private trader. So they go to them and then they sell their market. So rather than studying every single tehsil is one aspect, and studying entire taluka, which also give entire district, which also give another dimension to this scope. Yeah.
yeah,
So
yeah.
can there also be a possibility that a lot of people may not be actually selling to mandis directly and selling to different markets?
Hmm.
Just wanted to ask, do you think it can be a significant um,
Hmm. Uh, yeah, I mean, maybe Sanket might know more since he's from
Yes.
the area,
So
but yeah.
uh,
Hmm.
in my dashboard, let's assume that there is a Trambak tehsil. In that tehsil, there is no mandi. So they try to approach the closest mandi, which is Nasik district, and if not, they try to approach one of the most biggest mandi in Nasik, which is located in Nifad, Nifad, Lasalgaon mandi. So
Great.
What I meant to basically ask is, suppose my village is in, say, Kanpur Dehat, and if there is mandi, or even if there is not, regardless of that, some of the farmers directly sell
yes,
to
they
customers in the
they sell
market.
to a traders. So yeah,
Yeah,
yeah.
so why I was thinking ki is can there be a case like that, or can we infer
Yes,
anything
so
from that?
data.gov, that website, they provide the all of those data, which include the uh, same information, both the mandi level, and also there are private traders who trade and sell the onions.
Okay, okay, thanks.
Yes,
Uh-huh.
yeah,
Great. So, in the interest of time, let's move to another other project discussions. Um, I can see Anoop and Kaustubh are here. Anoop and Kaustubh, should we discuss about the water body ecology dashboard?
Sure.
Sure. Yeah.
Maybe I can just quickly show what I've done so far, and Kaustav can probably come in at any point. Yeah, so far, yeah, I think, yeah, Kaustav already gave the context of what the project is. So just broadly, we are trying to get some biodiversity data for the tanks of Anikal. So we are looking at INAT and eBird data. So the last week I've been trying to uh, yeah get the data basically. Uh, yeah, don't have too many results to show, but I think uh, maybe I'll just share my screen to very quickly show uh, what I've been doing. Uh, yeah, so I think you're seeing my Python screen. So I'm doing this all on Jupyter notebooks locally, so nothing too fancy. Um, so basically,
Anup, if you could
yeah,
zoom in a little bit.
sure.
Uh,
Is this better?
yeah.
Yeah, though there's not a lot to share, I just wanted to give a kind of sense of what I'm doing so that it might spark some ideas and inputs. Uh, yeah, I will basically use the data set of the water bodies in Anikal and the boundaries from the core stack website. So I found the GeoJSON files there. So yeah, just basically I've been trying to understand what's in the data set and understand the layers that are there. So based on that, yeah, I could isolate around 130 lakes which have a proper name. So this is a water body data set as well as just a taluk boundaries data set. So I've basically combined those two. So I isolated around 130 lakes which have a proper name, and they also coincided with lakes with coordinates. So I assume that these are the relevant water bodies that will be useful for our study because without the coordinates, we won't be able to map the observations to the respective lakes. Uh, yeah, and then I just identified the lakes which are located within Anekal. It seems like there are a few lakes which uh, exist in the data set, but which are not in the exact Anekal boundaries. So I just played around a bit. Uh, to I eventually came to around 104 lakes. Yeah, this is a lot of trial and error, and there are around 104 lakes inside Anekal and around 26 outside Anekal. So yeah, I think the analysis will then be focused on these lakes which are inside Anekal. Um so I think once we have that, then so also I got the bounding box for Anekal from the shape file, and INAT lets you INAT has a very easy to use API where you can specify the bounding box as well as the time period for which you want the observations, and you can query the data within those uh, within those bounding box for that specific time period. And because this is like for the whole taluk, so there was a lot of data. So I basically split it up into quarterly fetches. So each run it would get data for 1 quarter. Um and then I did this from 2013 onwards. Uh, and then I have the file saved locally. For 2013 to 2017, there's not a lot of data, but the recent years have decent amounts of data. I've queried both research grade as well as needs ID. So these are like the two quality grades. I've left out casual. I think this yeah, I don't know if you want to restrict it to research, but I think these two are the relevant ones. And I've gotten all INAT observations, regardless of the order or the taxon or any such classification. So the data is available. I've saved it locally, so we can already run all kind of analytics on it. This is for 2013, but yeah, I have it for all the years. And then I looked at eBird data. So the eBird API works a bit differently. So you can't do an API run like INAT, but for a particular district, you can download complete checklists. Uh, so so then what I did was I actually found a resource where they'd already downloaded uh, 10 years of data for Bangalore urban, uh, which is also what we want because Anikal also lies within those boundaries. And then yeah, the checklists have all the columns which are relevant for analysis. It has the observation date, it has the latitude, longitude, and the common name, scientific name, all those things. Uh, yeah. So then, yeah, so basically, I have the data now for the last 10 years or so, and then yeah, once I downloaded the CSVs, I assigned, since they have the latitude, longitude, I tried assigning them to water bodies. I have like a small buffer, 500 meters buffer. I actually, yeah, 500 meters buffer. Maybe we can also make it variable depending on the lake size. But for now, I have a very coarse 500 meter uh, buffer, and I've assigned the eBird observations to corresponding water bodies. Um, Yeah, so I'm in the middle of it, but for instance, this is only for 2016, so I could find 34 lakes with observations, and then when you run the same analysis for yeah the whole data set, I think it comes up to around 91 lakes which have like data. Uh, yeah, and some debugging I was doing. And then I think so, there is some redundancy with the naming. I think they're named like there are like 15 lakes which have like overlapping names. So that's something I'm still trying to figure out. But yeah, you get the sense, right? Like you have around 6 or 7 lakes with uh, data. Um, and yeah, there are quite a few lakes with 10 years of data, which is good, and quite a healthy number of checklists. So this is where I'm at. And yeah, I think for the next steps, I'll probably need input from Kaustubh on what he exactly wants, because I think with this data, we can analyze a lot of things. I'd like, for instance, for the other project, we had looked at water birds and, did a trend analysis of how their detection frequency has changed over years. But yeah, I think for this particular dashboard, it would be interesting to get Kaustubh's inputs on what exactly he wants.
Should I say something, Adi?
Yeah. Go ahead, Kaustubh. Yeah.
So, I mean, one thing it will help me to understand is if maybe Anup and you can explain like what this allow. I mean, because I'm still a bit confused as to what this exactly allows one to do. I'm guessing in an automated fashion or in a algorithmic fashion, right? Like if I have a
Hmm.
query or something, is
Hmm.
one thing I got, Anup, was that you can capture all the INAT data for a particular area if you have a bounding box for it. Is that correct?
Yes, that's right.
But is it possible to subdivide that in any way, or is it possible to do it for different lakes? I don't know if that's possible.
I think technically it is possible in the sense that we already have the shape files of the lakes.
Yes.
So then from that you can extract the extents of the lake, and then in the API run you can use that as your as the bounding box.
Okay. But then would
Uh,
one have to do this manually, or how does one do this?
yeah, correct me if I'm wrong, Adi, but I think you can schedule these API runs like once a month or something of that sort.
Right, right. So basically, what we have in mind is that right, so think of it as a pipeline that can get triggered, right, at some
Mhm.
frequency. So what we can basically do is that since we have all the shape files, we can go shapefile by shapefile, push the APIs to INAT, get the lists. Uh, uh, we can also maintain some checkpointing that send me information after the last date until which we already have it, right? And then all of this can then be automatically put into a database and which can then be, right? So on the water body map, you can imagine that if somebody goes there, then it will pull the latest information from the database. Yeah.
Okay. So it could get displayed on the water body map itself.
Right, right, right,
Okay,
right.
okay, got it.
Yeah, yeah.
And would the same thing hold for the eBird data, Anup? I mean, again, I don't know.
I think eBird API works a little differently. It will give you data for the last 30 days around the location,
Okay.
but it's not as dynamic as the INAT API. They still have an API, but it seems a little more basic uh, than compared to INAT.
Okay. Okay. Got it.
But
So,
eBird also, sorry, no, I was
no,
just
go ahead. Go ahead.
asking,
Go ahead.
eBird also allows, I mean, the checklists have the lat long. That's how you were able to link it with the water
Yeah, yeah,
body. Yeah,
correct. Yeah.
awesome. Yeah, yeah, great.
Okay. So again, this is something that could be dynamically updated. Is that correct? Or
Hmm.
uh,
So what we can do is we can have whatever we've downloaded as a database, and
mhm.
then the dynamic runs can kind of append to that database,
Got
uh,
it.
so that you have both the historical, you get a sense
Yes.
of the historical data and the current data also feeding into it. So we could have both.
Got it. So I mean, because one thing I'm thinking about is also kind of a state of lakes in Anikal report. So this would be something which would be very useful for that, right? Because
Mhm.
if one could also look at historical trends and then that year's.
Yeah,
Uh,
yeah,
uh,
yeah. So for the cascades, that's what we did, and it's quite interesting. But we
mhm.
looked at specifically at like water birds, because
Got it.
when you say birds, there's a lot of different varieties of birds, right?
Hmm.
So then we just looked at the trend of water bird population. We divided the water birds into like different guilds based on the
Got
space
it.
they occupy in the lake. And that really, and if you have like 10 years of data, it'll show some really interesting results. So at
Okay.
least for the 10, 15 lakes where we seem to have good data, I think it might be interesting. It will
Mhm.
generate like statistically.
Okay.
For that, I think, yeah, we need to kind of be sure of what we want to,
Got it.
uh, yeah, what we want to see. Sorry.
Okay. Yeah.
Great.
So maybe we should definitely chat. I mean, outside of this meeting, I think, and we can schedule a time, um, which is convenient for you and me.
Sorry, I lost all
No,
of
no,
you
I
for a
was saying.
second.
So then we should definitely chat outside of this meeting, and maybe
Yeah,
we can schedule a time outside. I mean, later
y-
on.
yeah, that would be great, Kaustav. It'll also give me a sense of direction about
Yeah.
what you exactly want.
Okay. Um, so, I mean, Adi, in terms of the core stack, is this helpful at all? I mean, like, I don't know if this can expand into your own work.
Yeah, yeah, no, exactly. Anup has already, mostly figured out the APIs and right, and with your inputs, let's figure out what analytics will be useful to build
Will be
out.
useful. That's
Yeah.
right.
And then we can work with Anup to basically build this into a pipeline, right? Which we can then run not just in Anekal, but basically anywhere, right? So then we can just go tehsil by tehsil, district by district, right? And keep populating. So that would be super cool. Yeah, Anup, one question that the water bodies that you obtained,
Mhm.
you use the water body data that we had published on the course stack for Anikal?
Yeah,
Okay.
yeah,
Okay.
because apparently that
Yeah.
also feeds into the Arnicle dashboard, the Tanks of Arnicle website dashboard, right? If I'm
Okay.
not wrong.
No, actually,
Yeah.
currently it doesn't. Currently, Anup actually did all that mapping himself.
Okay.
Right. But over there, how did the water body name you picked up from the ones that we had populated in that
Mm.
data?
Yeah, so I
It
just
was
picked
in
up,
the JSON.
yeah,
Okay.
it seemed to be
Very.
named after the village, which I think is
Hmm.
probably the that seems to be the convention.
Okay, okay. Yeah, I know. I mean, I'm actually happy to hear that that's kind of working. So, the name actually comes from a water body census that was done by the government.
Okay.
So, the way that particular data set has come together is that using remote sensing, we detected the water bodies. Yeah.
Hmm.
But we just know the polygons, right, that we can build with all of that. We then intersected it with the water body census data.
Mm.
In that census data, they had just published the lat long. And
Okay.
then we matched it if the lat long was entirely intersecting or within some buffer of 100 or 150 meters or something like that.
Yeah.
So yeah. So I mean, I'm glad that it's able to pick up the names
Yeah.
and yeah,
And
cool.
what I see is for lakes outside Arnicle, it's named as BBMP ward or something of
Okay.
that sort.
Okay.
So those ones I try to keep out because typically they fall outside the
Uh-huh.
Arnicle boundary.
Okay. ठीक है. Yeah, we can clean up many of these things as we move forward. Great. Yeah. No, I think this is super cool. And yeah, I'm sure Kaustubh will be able to
Yeah,
guide
I'm quite
on.
excited.
Yeah.
But
Yeah.
one thing I can
Yeah.
do is I can share our spreadsheet where the lakes that we have data on. I don't know, then maybe you can check if that intersects with your particular
Hmm.
set. Uh,
Hmm.
Yeah. I think
Yeah.
that'll be a useful exercise to do just to make
yeah,
sure we have the right
okay.
data.
Because the research assistant who was working on the sheet like cross-checked it using two or three because she ran into the same problem of the name, and it
Mm.
has different names in different records.
Okay.
Sometimes it's the village name, sometimes it's something else, and sometimes the lake can be divided across two or three different villages. So then,
Yeah.
Hmm. Great. Cool. No, fantastic. Uh, Also, Anup, actually, we can you tell us a little bit about yourself also? I don't think we actually ever got introduced in that way.
Yeah, sure. I'm Anup. I'm an engineer by training. I've been working in the renewable space, solar energy space for the last 10 years. Uh, yeah, I've always been interested in biodiversity and yeah, also got interested in data along the way. So I've been looking to work on projects at the intersection of the two. So started 2 years back. There were some like open city data projects that they open for everyone. Yeah, so that's what I've been doing. I'm just trying to dabble in this space, which seems to be super interesting for me.
Great, great. No, that's cool. Yeah. And yeah. So I won't spend time in going around the room with introductions, but I think as we, whoever asks questions and whoever's going next, so right. So please do introduce yourselves and yeah, I mean, yeah, it's very exciting to see this community kind of emerging. Yeah, I myself am Adi. I teach at IIT Delhi, and right, so we've been working on this with a lot of my students and then engineers at the Commons Tech Foundation, which is a not-for-profit that is doing most of the engineering and software development for the core stack. Great. So I think Shivam wanted to go next. Shivam's been working on scraping data. Uh, and also, Sanket had a question about how to distinguish between water bodies which are in rivers and stuff, right? So that's an important point also just to understand the data set that right now the water bodies that we've identified, we are just spotting water pixels. Yeah. So, and we don't know actually whether it's a part of a river or not. So actually what we're going to do is that we also have the rivers map that has been released by the Water Resources Institute, sorry, Information System, WRIS. So we will intersect that reverse map with the water bodies that we have found, and then we'll be able to label, right, that what we are calling a water body is actually a patch of water that falls inside a river, or whether it is something outside, like an independent kind of a water body. Yeah. And then that data, if you go deeper into the GeoJSONs, then that data has a lot of information about what is the area of the water body uh, based on the remote sensed information. And see water availability, right? That in the three seasons, right? Monsoon, post-monsoon, and summer season, how much of that water body had water, right? So that's like a time series data, which is in the GeoJSON. Um, and then we've also intersected these water bodies with the water body census. So that brings a lot of other information, like what is the name of the water body, and which I mean, why was it created? I think it also has capacity information, right? So, but that intersection also doesn't. It may not. The data may not have intersected for all water bodies, right? So you'll also find for that piece, you will also find many of those data points as missing. Yeah. Yeah. But yeah, I think this is great. So as you know, when you go deeper into these data sets, then please keep asking questions, and we'll help you understand the background. Um, yeah. Shivam, you want to go next?
Yes, good afternoon, everyone. I'm Shiva Goyal. I'm a student of Artificial Intelligence and Data Science studying in third year. I'm from Dattamanik Institute of Higher Education and Research, Wardha, Maharashtra. And currently, I'm working on agri sciences data collections at tehsil level. So, as I discussed last session, that just a second. I will share the screen. My screen visible.
Yeah.
Right. So I've been collecting data from this government website, which displays the data of the sea level crop grown in what hectares. So this is the interface. We select first year, state, district, tehsil, and then table section. Will go to profit pattern, and then in social group, select all social groups so that every social means the total number of hectares will be covered. So when we click on submit, you can see the data. Here you can see the crop, of what so how many hectares of what crop is grown. So this table, the conclusion here is that in the Andaman Nicobar state, the district Nicobar, Tehsil Camper Bay, the only 1 hectares of crop is grown, paddy is grown in that area, particular area. And likewise, there are total 6,500 tehsils combining 36 states. And so that's it. And last time we discussed that the automatic scraping of the data from the website, because the website doesn't support multiple multiple requests at the same time, and it crashes. It crash if someone tries to attempt in both the ways. So this is the error I faced one time, that the server side it got disconnected, and it was down for at least 1 day or 2 days. So they have resolved the issue, and the website is working. So last time I developed the script that will automatically scrape the data and store it in CSV file. Just use CSV file. So right now, this is the previous number, because the scraping is still going on this thing. So currently, Andhra Pradesh state data has been scraped, and we'll move on to next state soon. So it will directly collect the data in CSV file, and to continue scraping this file even after timeout of the website or if the scraping is stopped. So I created a system that will automatically send me an alert on the Telegram. The script has stopped and at what time it has stopped, so that I can restart the script. So I've been trying to make another script that automatically restarts the scraping without me interfering or without any interference. It will directly restart the script n number of times. So I'll just show you the demo. Basics, the script of scripting. So you can see the scripting is starting. It will directly open the Chrome. And as you can see, I just received a notification that it has started successfully. So as you can see, it will directly build the parameters and directly script it automatically. You can see as there is no record, so it will continue to the next step. The site response is a little slow, so it will take time. So to scrape data on one text, it takes at least 10 to 12 minutes or maximum 15 minutes to scrape data of one text. So the data, I can see the progress here in the terminal. So if something happens, I can recheck it and correct it. So I will show you a demo that if I just cancel this close this tab, it will directly stop. So and I will get the data alert that the script will stop and be able to restart the script. So to solve this problem, I created another script that automatically starts if something happens. So I will just run this script. It will give me an alert that okay, started and also you can see it has started. I close it. Has given me the error, but it will automatically restart in 5 seconds. You can see it has automatically restarted. It has restarted. Notification restarted. I have to improve this script because there are bugs in it. Automatic restarting.
Shivam, we can't hear you properly because of the disturbance. But this is very good. This is very good.
Class has started right now.
Yeah, I can understand. Yeah. No, that's cool. No, this is very good work. Yeah, why don't you continue? And I'd also suggest that, this experience that you're getting with scraping, this will be very valuable. So you should also document that kind of separately. It'll be very helpful for others who try to do this.
Sure, sir. So actually, in the month of March, I'm having internship of 6 months. So there is internship period of 6 months. So I've been looking for the internship and just want to ask if there is any vacancy or any position for company or I can do something.
Sure. Yeah, no, sure. So can you just drop an email and we can then discuss this offline?
Sure. I'll show you with the resume.
Okay. Yeah. Sure. Great. Okay. Is there were some other people who wanted to also discuss. Can you please go ahead? And Shivam, it will be great if you can mute yourself.
Sir, just one thing.
Yeah.
Amit sir has asked, Amit sir has suggested one solution. So just want to reply to him that I tried it, but the website doesn't support it. But I will retry it once more. But while developing this basic script, I've tried it, but the response of the website is output. The poor handling of the website. That's why it is not possible, I think. But I will try once more.
Great.
Thank you, sir. I'll be taking my leave.
Thanks. Thanks, Shubham.
Thank
Fantastic.
you, sir.
Yeah. Chandana or Gautam, is there anything you want to discuss?
No, sir, no, sir.
Okay. Great. All right. Great. No, thanks, everyone. So, yeah, let's stop the call for today and we'll continue next week. Yeah. Okay.
Thank you, sir.
Thanks. Bye. Bye, everyone.